possibly have one next year. I am Vice President of Construction for a national builder and developer. We are building a project in New Brunswick. I'm going to go through here. I'm going to show you how the construction process works, show you some photos and different items as to how we approach a project like this, how we decide what we're going to build. What we are building in New Brunswick, for those of you who are familiar with the area, we're building down on New Street, between New and Nielsen Street, right off of George Street by the Heldridge Hotel. We're building an 8-story apartment building, and it's going to house 393 apartments. We'll have a pool on the roof. We're going to have a gym inside. It's going to be a very nice project. But I'm going to show you a little bit about what we do. As you can see from the picture, if you look at the dark yellow line, that is the building that we're going to be building. That's the footprint. That's actually where it's going to be. All the little blue lines, the blue squares throughout the project, those are buildings that were there at some point in the history of this site. What we do is we go and we do a study. We do a phase 1 environmental study, and what we do is we go through and we have people do research as to what the historic uses of this property once was. And what you have here, you have on the left-hand side, you have New Street. On the bottom is Nielsen, and on the right is Liberty Street. Up above that, which is not located here, would be George Street. And as you can see through the center, you see where it says Schuberman? That was a street that was historically there 75, 80 years ago. Nobody would know that, but we do that research, we look at the site, and that's how we determine what our next process would be. So this next picture shows you what we present to the city. This is what we call a traffic plan. And what this is, this shows how, when we build the project, how the traffic flow would work around the project during the construction process. And what it shows is, you see the arrows, it shows how we're going to control traffic, how we're going to address the different problems of traffic in and out of the site. So these are the first 2 processes that we attack when we're going to decide on a project. And first being the historic use of the project, next being the traffic flow as to how we will present it to the town. After that, as you can see, this is the site now. Previous to us being involved with the project, it was a parking lot. And what we do then is we take our historic survey of the project, of all those buildings, we look at the site, we then come into the site, as you see, and it's just all asphalt. So the asphalt on this project means that it doesn't accept any water, nothing perks down to the property, and as such, it's a complete, everything just runs right off this project. It doesn't accept any water, so it's not very good for the environment. It doesn't allow the water, so we have to control all that water flow. And as you see in this picture, this is where we start actually taking the asphalt out. The section up above, we remove the asphalt so that we can begin our further investigation. As I said before, we did a phase 1 environmental investigation, and that shows where all those buildings are. And then we got to take the asphalt out so we can do our phase 2. And the phase 2 is much more in depth. We start drilling down into the earth. We start looking for oil tanks. We start doing all of those kinds of things so that we can prepare the site for the building that's going to come. As you see here, we've got a machine here. We're doing some tests. We're digging some test holes so that we can check what the soil conditions are, and we're moving on from that so that we'll take soil samples and we'll send them out to a lab, they'll be tested. As you can see in this picture, the machine over here, that's called a milling machine. And that machine will drive up and down that site, and it just grinds all the old asphalt right out of the earth. Grinds it all out. We grind it up into a bunch of little pieces, we throw it into that truck, and that'll go back to be recycled. That'll go to an asphalt plant where we'll take that material and make more asphalt out of it. Years ago, we used to just rip it up with machines, throw it in the trucks, take it to a landfill. We don't do that anymore. Everything is much more environmentally conscious. Don't get me wrong, it also saves us money. We're not throwing items in the landfill anymore. We're taking it and recycling everything. This is after we took out all of the asphalt. We start digging some holes. We start putting some piles of dirt in. Now this dirt, which is pretty historic to the area of New Brunswick, this is shale. And the beauty of shale is it's a very hard, compacting soil. It also doesn't hold a lot of the contaminants that you may be researching through your science classes about what's actually in the soil. Shale's good. It's a very rocky soil, and it's very good for us for construction because it bears a lot of weight. Also for us during construction because the contaminants don't really stay in the soil. They purge themselves. They move on somewhere else. They dissipate. As you see here, as I told you, it's all an environmental process in the beginning. What we have here, these two gentlemen, one of them is our LSRP. I don't know if you guys have learned about an LSRP. An LSRP is your licensed site remediation professional. And what we do is we hire an LSRP to come in, and he is our go-to guy. He is the guy that finishes the phase 1 assessment, performs the phase 2 assessment with us, and then tells us where all the areas of concern are. So what we have here is we have our LSRP, and we also have a geotechnical engineer. The geotechnical engineer is the guy who tells us that the soil's good. Because with all of those little blue squares that we had in that first slide, those houses all have foundations on them, and the grading that occurred around them, and potentially they don't bear the foundation that we want to put in. So we have to dig deeper and find better soil for that. So the two gentlemen here are very important to the project, our LSRP and our geotechnical engineer. Now what they're looking at here is while we were digging, that's an oil tank. So oil tanks typically, as with all of those little squares you see on that first slide, each one of those buildings at some point had an oil tank. Because back in the day, 100 years ago, you heated your house with wood or you heated it with oil. And to have oil, you need a tank. You need to hold it somewhere. So while we try to research the site, and we use a process called ground penetrating radar, which is a guy who walks up and down the site with a big box, and he tries to find the oil tanks. Sometimes we don't. So in this case, we were digging, and we just encountered that tank, and these two gentlemen are now reviewing the process. And what we'll do after we find that tank is we'll take soil samples around that tank, we'll send it out, we'll test them, and we'll decide how much soil we're going to need to take out around that tank if any soil was contaminated. Sometimes we're lucky enough that the tank didn't leak any oil. Sometimes it was dry from many years ago, and as such, we're lucky enough that we don't have soil that we have to take out. But in this case, the tank was pretty banged up, and we ended up having to take some soil out. So here is our LSRP, and he has encountered another oil tank. Now this one you can barely see. There's a little bit of a radius. He's holding his tape measure, and just about halfway up that tape measure, you'll see a radius. So this was a tank we were aware of, and we excavate around it. We find the end of it, and we excavate around that tank, and we try to find the tank, and we dig it up. Now in this case, this is after we're starting to dig out the soil. I'll get onto some more tanks here, but this is just the site and what we end up, excavating. Now, what you see here, this is when we bring in our environmental professionals, our cleanup professionals. What we have going on here is you see the two blue tanks there, and the hose is coming out of them. That's like a big vacuum. And what's going on here is these gentlemen are vacuuming out the inside of that tank that you see adjacent to that. The one guy's bending over, and there's a hole in the tank next to him, and they're vacuuming out everything that's in that tank.
So if you remember reading the article
That's exactly what this is. In some cases, we'll bring in an enormous vac truck. In this case, they have a trailer-mounted vac, and what they're using is the blue tanks will collect the contaminated material and hold the contaminated material in them, which will send out to be disposed of properly at a registered landfill that will take that material. Now here we have, these are tanks. One of them says sludge on it, the other one says dirt. And that's what we pulled out of these tanks. So we take these tanks that are underground, we clean them out, we test the soil around the tanks after we get the tank out of the ground, and we put this material in these little drums. We shipped off to a registered facility to remove it, to dispose of this material. Here's another tank that came out of the ground. After it was cleaned up, what we do is we take those tanks and we crush them down. Because the tank is cleaned inside, we crush it down, and it's only a piece of steel. We take it to a recycling facility. We actually sell it to the recycling facility after they're cleaned up. So, not that there's a lot of money in it, you probably get $20 for that tank. Now, here's a big tank that we encountered. And you see our LSRP in the photo on the right, or on the left, over here. What we've done is we've uncovered the top of the tank. The little line coming off the side is actually the supply line to the building that this tank was actually for. So it's just a little 3/4 inch line goes to a building, whatever the furnace was, and it just heats. So what we do is we uncover the entire tank, and then on the right you see we cut a hole in it, we pull it out of the ground, and we clean it up. And then this tank this one will get crushed down and shipped out as well. The same process occurs in this. We have the environmental cleanup guys come in with their vacuums and they suck everything out of there and they clean all of that up. We just put a dump truck in here because this is how we get all the soil off the site. All the excess soil, because when you're digging for a building, as you saw in the beginning, that land was flat. For us to put a building in there, we got to dig some of that dirt out of the ground. We got to take it out of the way because we're going to replace that dirt with concrete. Concrete's going to be our foundation for the building. And what we do, we got to test the soil, make sure that soil is clean, and then ship that soil to either a site, if it's not clean, to a site that's going to take that soil and clean it up, or we ship it to another site that's looking for clean soil. In our case, New Brunswick didn't have much. The site was clean. We didn't encounter any dirty soil on our site in New Brunswick, other than the soil that was around those tanks. Around those tanks, we encountered some dirty soil, as you saw in the blue drums. That gets shipped off to a registered facility. In New Brunswick, all the rest of the soil, that shale dirt, we just shipped it to a site in South Brunswick that was in need of material. And this is actually on the site in South Brunswick. We take that truck, we load the dirt in, and we take it down and just dump it down in South Brunswick on a site that needs dirt. And what you see here, this is when we started digging for our foundations. And everything around here is historic fill. Historic fill is just a classification of dirt that says that it's been there for many, many years, but it's not virgin. It's not the original ground that was there. And the way you can see that is in this photo. We've dug down to the bottom of our excavation where we're going to put the concrete. But if you see those lines in the soil, you got a nice, strong, lighter colored line. That's actually just ash. Ash from fireplaces or something like that. Again, 100 years ago, a lot of people burned fires to heat their home, and they would dump ash. Sometimes they would just take an empty lot and they would fill it up with ash. And so what we end up is with a vein of about 2 feet of ash in various portions of this site. So that's representative, and that's where our geotechnical engineer comes in and tells us, all right, that stuff's okay to leave there, this other stuff is not good. We got to take that out and ship it off to another location. Same thing here. you can see the different layers in the soil. That white layer there is actually a layer of concrete. It's about 6 inches thick, and it was just a concrete sidewalk or something of that nature that was there many years ago. And then down below that, you'll see the soil looks very rocky. That's actually shale, and that's what shale looks like. It's very rocky, and you can dig through it. It breaks real easy, but it's very rocky. So,
please excuse the interruption. Substitute teachers, if on your schedule it says prep or common planning time, please report to the main office for an assigned duty. Thank you.
So after we end up digging out all the dirt we need to get down to our level, this is what we end up with. We dig it down, we run a steamroller over it, smooth it all out, and then we'll begin to put our foundations in. What we're building next to here is a parking garage. It's a 7-story parking garage immediately adjacent, and that's what adjacent to our building, and that's what that is. Now, here, this is a drilling rig. We'll bring this drilling rig in sporadically throughout the project. This drilling rig does 2 things for us. It tells us what the soil conditions are below that area of the site. What we do is we drill down and we keep taking core samples out. And we'll go down sometimes in excess of 100 feet, sometimes more. And we'll get core samples of all of that dirt. And our geotechnical engineer is there, and he takes the samples back to his shop, and he determines what type of soil it is and how much we can put on top of that soil, how much weight it can carry. With that, we also take those samples and we send them to an environmental testing lab to make sure that we're not building on top of anything that is hazardous. You know, while there may not be hazardous materials at 2, 3, 4 feet below soil, there could be hazardous materials 20 feet down. If we encounter those soils, what we'll end up doing at times is we'll put a vapor barrier on the site, and we'll just vent the building out. Sometimes they're not that bad, so we'll just put a barrier in so people know that it's down below that, it's bad, but up above it's okay. Now here, as you can see, we're actually installing, we're bringing utilities to the site in this photo. This is a big water main that's out in, right in New Street, that's in Nielsen Street. We open up the site, we dig down and find the existing water main that's in the street, and we bring a new water main into the site so we can handle our fire protection and water services, so everybody can take showers and the sprinklers work and everything else. So this is actually where we dug in the street, found the existing water main. We dig a small hole, we find the existing water main, and then we'll end up cutting that and putting a valve on it and run the water to our site. This here is just another picture of the site as it's starting to progress. Adjacent to the parking garage over here, we have a bunch of concrete block, and that'll end up being a concrete block wall that'll go up 7 stories in the air. Imagine those guys putting the concrete blocks up going up 7 stories. Another picture of how we bring the 2 foundations together. And here you see, after everything's done, we're building the foundation for the building. These actually little squares, and that's actually, we're putting forms in to hold the concrete. We dig a trench, we put forms in, and it holds the concrete to build the building. The foundation of the building is the most important thing. Once we get the environmental work done, and the excavation, and all the utilities to the site, the next most important thing is the foundation. They always say you can't build a good building, you can build a good person without a good foundation. Now here what you see is the footing, this over here, that's concrete, but adjacent to that, why I want to show you this picture, it's this black tarp here. The black tarp along the side, kind of sticking up in the air, that's called silt fence. The silt fence is another important part of the project. The silt fence needs to be installed and maintained on a regular basis, and what the silt fence does is it controls the flow off the site of any soil, any sediment. You get a lot of rain on a construction site. I'm sure you've all seen it. Sometimes you see dirt running down the road. Well, that's a bad thing. That's a bad thing, and the Department of Environmental Protection here in New Jersey, we get in trouble for letting that soil run down the road. So what we do is we protect it with silt fence And that'll allow the water to flow through, but it's got very, very fine meshing, and it holds the soil on site. It needs to be maintained on a regular basis, and so